Welcome to lesson 6.2. We're going to talk some more about, or we're actually going to talk about point slope form. We're going to talk more about linear equations, but now we're going to transfer from slope intercept form to point slope form. So when you have point slope form, you're using a point and the slope to create your equation. Right? So you have to make sure that you are being very careful when you're reading, when it's asking you what form to put it in. Point slope and slope intercept, two different types of equations, okay? So first of all, we're going to take a look at this first explore problem, deriving point slope form. So how we're going to find it. So we're looking at this problem and we have a line that has a slope of 4, so m of 4, and we have a point of 2, 1, right? And we know the 2 is our x and the 1 is our y. So we know that we can find the slope by doing y2 minus y1 over x2 minus x1, right? So we are going to substitute this information into our formula. We know that in this case, we don't know one of the y's, okay? So we're going to substitute 4 for m, and we are going to replace y1 with 1 and x1 with 2, our 2 points. Right? Going from there, I know that I can multiply both sides by x minus 2. Okay, so if I want to get rid of the division problem, so if I'm looking down here at the division problem, I want to get this and I want to move it over to the side. In order to do that, since I'm dividing by this whole thing, I can multiply by the whole thing, but what I do to one side, I have to do to the other. And by doing that, so since I'm multiplying, I'm moving it over to the other side. Right? So then I end up with the form 4 times x minus 2 is equal to y minus 1. And this is the form, so when you have a problem or an equation that is in this form right here, so the m times x minus, and I should say x2 minus x1, I'll write it out in full for you here. So point slope form, I guess you don't need it in 72 font, is going to be m times your x2 minus x1 is equal to your y2 minus y1. Okay? So then this is how we go from finding the slope, so the equation to find slope, and how it transfers to point slope form. So it's how you get from here to here. So the equation that you derived is written in what's called point slope form. The equation y equals 2x plus 1 is in slope intercept form. How can we rewrite that in point slope form? So basically, when you're talking about point slope form, you're looking to have your points separated. And in this case, you have the y and you have your x, okay? But this is also a y. So let me actually do this in blue so we can see the difference. So your x's are your blues and your y's are your reds. So we want all the y's on one side of the equation and all the x's on the other side of the equation. Okay? So in this case, we know that the slope intercept, or that the y-intercept, my goodness, I'm stumbling over my words here. I apologize for that. We know that the y-intercept is 0, 1. Okay? So we can do all this work and move things around, but what we could also do is we could just take the form and say, well, I know that my m is 2, my slope is 2, and I have x minus 0 is equal to y minus 1. So the y moved, so both y's now are on the same side, and both the x's are on another side. Now, what you also will notice is that in this case, you're going to end up with just 2 times x. So what I mean by that is, here, if we were actually to take this and solve so that way all the y's are on one side and all the x's are on the other side, I could actually subtract 1 from both sides. So here's my red, subtract 1, and I get y minus 1 is equal to 2 times x. This would still technically be considered point slope form because here, x minus 0, no matter what x is, you're just going to get x. And you're going to end up with 2x equals y minus 1. It doesn't matter if it's written this way with the x's on the left and the y's on the right, or if it's written this way with the y's on the left and the x's on the right. They both mean exactly the same thing. Okay? So you have to be able to look at the y-intercept and say, I know that this is 0, 1 as a point, and so I can plug that point into here and get my equation. All right, so here we go. So here's another example for you just to have. I'm not going to go over the example. I'm going to go through the problem and work through an example with you. So we have the slope of 0, and we have -2 and -1 are on the line. Now, when the slope is 0, I want you to think of our slope dude. So we have puff, puff, positive, and when it's puff, puff, positive, we know that he is going up. Nice. Negative. 0 fun. So since this is 0 fun, you know that this line is going to just be a straight line. That's why there's no slope to it. It's a 0. Right? So it's that horizontal line that gives you the 0 slope. Right? So then in this case, to put it in point slope form, we're just going to substitute our pieces. So point slope form is y minus y1 equals m times the quantity x minus x1. So I substitute my numbers in. So I have y minus -1, because that's my y, equals 0, which is my slope, times x minus -2. But now here's the thing. When it comes to multiplying 0, anything times 0 is 0. So anytime you have a line that has a slope of 0, it's just going to be your y value minus the other y value is equal to 0. Now in this case it's addition because minus a negative is the same thing as plus a positive. So when you have that 0 slope, when you're in point slope form, you're going to have 0 on one side of the equation and your y on the other side of the equation. Okay, so in answer to the question down here, suppose that you are given the slope of a line that is 0. What is the only additional information you need to write the equation of the line? Well, like we said, even if you have the x, anything that you put inside this parenthesis here is going to get multiplied by 0, and it's going to give you 0. So you don't need the x. You only need another y value. And the only reason that you need that y value is so that way you can put it into the other side. Okay? Because the x value is going to stay the same the entire time, so there's not going to be any change. So that's why this is 0, because there's no change in that slope at all. All right, so now we're going to create linear models given slope and a point. So again, you have an example in A that you can go over and read through. I'm going to skip to B and we're going to work through it together. So Paul would like to shop for the best price to place an ad. Okay, so it's kind of important, but not really. A different newspaper has a base cost. Now, base cost. We know that that is the initial cost, and the initial cost is always our y-intercept. Okay, so in this case, it's $15. Okay, and with that $15, you get 3 lines. Now that's where this can be a little bit confusing. because for $15, you get 3 lines. It's not that you get 0 lines, you get 3 lines. Okay, and $2 for every extra line. So we want to know how much will an 8-line ad cost. All right, so in this case, we need to figure out our slope. Now, this is where it's confusing because 15 over 3 is not my slope, okay? 15 is the initial fee, right? It's the initial rate. So in this case, it's not going to cross it's not necessarily your y-intercept, but it is that base fee. So your y-intercept in this case was going to be 0 because if you pay $0, you get 0 lines, right? So be careful, and I know I said that it's the y-intercept, and I apologize, I misspoke, but you have to be careful because you have to know that this is where your graph is going to start. Okay, so in this case, I'm going to substitute 15 in for my y, and I'm going to substitute 3 in for my x, because when I pay $15, I get 3 lines. And I know that 2 is my slope because the rate of change is $2, so I go up $2 for every 1 line that I pay for. Okay, now to solve for 8 lines, I plug in 8 for x because x represents my number of lines. And if you're struggling with this, sometimes it helps just to picture a graph and say, okay, this would be my number of lines and this would be my cost. And this is always my x and this is always my y. This is where determining your independent and dependent variables is very important. Your lines are independent of the cost, but the cost depends on your lines. So then I know that since 8 is an x, I have to replace the other x value with 8. So I can find my cost, which is my other y value. Right? So when I do this, I get 2 times 5, which gives me 10. And then I'm going to add 15 to both sides, and I get y equals 25. So I know that the cost of 8 lines is going to be $25. Okay, so what you need to remember is if you can remember the formulas, all you're really doing is placing your numbers, or you're substituting your numbers in for your variables. Do not make this more complicated than it is. And I know I'm giving you a lot of information here and it might be jumbling you up. We're going to kind of simplify it here in a little bit because I want to give you as much as I can to help click with some of you. Because some people might see it one way and some people might get it another way. So just bear with me here. All right, so number 5, analyzing the relationship. So what we want to know is how is it related to the graph of the equation? Okay, so how is the ordered pair 8, 18 related to the equation that represents the situation? And in this case, the situation is that the other company gets 8 lines for $18. Okay, so the ordered pair, this ordered pair and this equation do not go together. These are 2 separate situations. But this ordered pair here is a solution to what would be the new equation. We don't need to know the new equation, but the ordered pair is a solution to the equation, and it represents a point on the graph of the equation. Okay, so anytime, so even up here, the point would be 8 and 825. So 825 is not only a solution to this equation, but it's going to be a point on the graph. And that's going to be the case for any points that work within your equation. Not only do they solve the equation, but that means that they have to be on the graph. Okay, so then we are going to move on to creating linear equations given by 2 points. So this is a lot like what we did with slope-intercept form. Now, point slope form means that you have to have a point and you have to have the slope. So here, again, I'm skipping to B. So here you have 1, 3, and 2, 3, and you know that they are on the line. So they're on one line together. Since they're on the same line, they have to be on a line that has the same slope. And to find the slope, I'm going to use my slope formula, and I'm going to plug in my numbers. So here I have 3 minus 3. Okay, so 3 minus 3 over 2 minus 1. 3 minus 3 is 0. 2 minus 1 is 1. 0 divided by 1 is 0. So I know that this line has a slope of 1. This tells me then that my line is a straight horizontal line. And you can tell that here by looking at the fact that your y value is always the same. That means your graph doesn't go up or down, it just stays at a constant spot. So now to put it in point slope form, you can choose either point. So in this case, the first one that I'm going to use is the 0.13. I put in 0 for my slope, and I plug in 1 and for my x and plug in 3 for my y. And then again, because of the fact that my slope is 0, I know that y minus 3 is going to be equal to 0. Okay, and then here I have the same thing. I plug in 2 and I plug in 3, and then if I go through and I solve, I know that y minus 3 has to stay because I don't know what y is equal to, well, all of this times 0 is just going to give me 0. So notice that even though our point slope form looks the same, when you break it down and simplify it, because of the fact that it has a 0 slope, it ends up giving you the exact same formula. Okay. I'm not going to worry about number 7. I just want us to move along here to create a linear model given 2 points. So we have an animal shelter that's asking all volunteers to take a training session and then to volunteer for 1 shift each week. Each shift is the same number of hours. The table shows the number of hours Joan and her friend Miguel worked over several weeks, and another friend, Lily, plans to volunteer for 24 hours over the next year. How many hours will Lily volunteer? Right. So in this case, they already give us all the information. And then here she's volunteering 24 weeks over the next year. All right, so our table also shows us the number of hours Joan and her friend Miguel worked over several of the weeks. So notice that some of our information is different. So what we're going to do is we're going to go through, and I pulled the information up here so you still have it, and we are going to analyze the information. So first, identify the important information. Sound familiar? It's important to know that Joan worked for 6 weeks for a total of 15 hours. Miguel worked for 10 weeks for a total of 23 hours. And we know that Lily will work for 24 weeks. We don't know how many hours that is, and the fact that it's throughout the year, not important, okay? So that's why it's not in here. Next, we're going to formulate a plan. Well, in this case, I'm not given the slope, and I'm only given points because I know that the number of weeks worked and the number of hours worked are our graphed information, our information that's going to go on the graph. And I know that my hours worked is dependent on how many weeks I've worked. So my x values are the weeks, and my y value is the hours. So I'm going to use my 2 points. I'm going to create the equation, and I'm going to identify the 2 ordered pairs represented by the situation, and I'm going to find the slope of the line that contains the 2 points because both of these points have to be on the same line. All right, so I'm going to use them to find the slope. So to start, I'm going to write the equation in point slope form. I'm going to substitute the weeks that Lily works for x to find y, which is the number of hours. Okay, so I'm going to find the slope. After I find the slope, I'm going to write out my equation, and I'm going to substitute the weeks for my x, so I'm going to put the number of weeks in for x so I can find out the number of hours for y. All right, so then here, I know I'm going to use the points 615 and 1023. And I'm going to substitute them and put them in the formula. When I do that, I get 23 minus 15 over 10 minus 6. And when I solve that, I find that I get a slope of 2. Okay. I know this up here is a little bit confusing. It's basically just telling you that you're claiming that weeks are your x and that y is your hours. All right, so now after I've done that, I am going to put it into point slope form. I can do this one of two ways. I can use either of the points. It doesn't matter. They're still going to give me the same answer. My formula will look different based on which points I use, but no matter what numbers I substitute, they would give me the same answer with either equation. Okay, so here I decided I'm going to just start with writing in 2 for the slope, and I'm going to use the point 615. I substitute 6 for x and 15 for y. So my equation is y minus 15 equals 2 times the quantity x minus 6. Or I could use the other equation, or the other point, and substitute 10 for x and 23 for y. Either will work. They will give you the same answers. Now granted, they look different, but if I plug in 1 for x down here, whatever it gives me here will give me the same thing here, even if I plug it in up in this equation. So now I'm going to substitute 24 in for x to help me find my y. All right, so here I substitute in 24. Okay, so I do y minus 15 is equal to 2 times the quantity x minus 6. And then here, I was still thinking of the second problem. No wonder I got myself so confused. Here I'm going to plug in 24. Okay, so now I keep my equation the same, but now that second x, I'm actually going to substitute 24 and not 2. There we go. Okay, so then now I have y minus 15 is equal to 2 times the quantity 24 minus 6. And when I do 24 minus 6, I get 18. When I do 2 times 18, I get 36. And then I have to add 15 to both sides, and I get 51. Okay, so now what I want you to do is I want you to pause, and I want you to try to solve the other equation. So I want you to pause and solve with using the y minus 23 equals 2 times the quantity x minus 10. And you should get to 51 as your correct answer. All right, so go ahead and pause, and when you come back, we'll take a look. Okay, again, I did the same thing where I substituted 8 for whatever reason. Who knows? So I will go through and I will fix that. All right, so I got 24 in for x, and when I do 24 minus 10, I get 14. And then 14 times 2 is going to give me 28. And when I add 28 and 23, it gives me 51. So I know that in her 24 weeks, she will have worked 51 hours. So notice, even though I used a different equation, both equations gave me the same answer. All right, we are not going to go through the justify part because I feel completely positive or I feel great about how you guys are doing with this so far. So if you want to go through and do the justify part, you absolutely can. At this point, I'm just asking you to solve the your turn problems. And as always, if you have any questions, please be sure to write them down or email me so that we can go over them in class.